What I'm going to talk about today is a very hot topic about AI and about the excitement around it, but also I want to look at some of the harder realities, because this isn't just some sort of magic, some sort of fairy dust that you scatter. It is something that needs to be applied in the right way to give value. And there's tremendous value to be had, but you don't get that just by taking a simplistic approach to it. Just by way of introduction and to set the scene, while I put AI in the theme, we know things like AI and big data and predictive analytics and so on are used a lot almost interchangeably. Just to set the context of what I'm talking about, for AI, we've said for many years the definition of AI is a computer doing something, but if a human being did it, you'd say was intelligent, that it showed intelligence. Now that encompasses a whole lot of things about being able to understand what you're seeing, being able to operate in the physical world like robots and so on. But at the heart of it are a whole lot of different areas. And when we talk about within this things like cognitive systems, as you'll hear a lot at IBM, for example, we're talking about systems that can ingest large amounts of natural language, that can learn what's going on in it, that can reason to answer some very tough and very demanding and very deep questions, and then be interrogated in natural language as well. What it's all about is trying to make good things happen. It's easy to think about these technologies being about data, and therefore saying we start with the data, what do we do from there? Actually, it's the other way around. What you're trying to do is get the right outcomes, whether that is people responding to medical treatment, whether it is people buying something that you offer them or staying loyal to them or not defrauding you. But to get to those outcomes, you've got to take the right actions. Your actions are going to be based on the highest quality decisions. Those decisions have got to be informed by insight and ideally foresight. And it's the analytics that extract the insight and foresight from the data. Okay, so that's the way I would always do it. This is all that matters. This is just a means to an end, although it's critical in trying to deliver these outcomes. And key to this is the foresight. It's the ability to look forward, to predict, to anticipate. And as you'll see in this, the key thing that we would say that does, it lets you be more right more often. It doesn't say you do use analytics, use advanced analytics, and you will always be correct, but it says you will have, on the whole, better outcomes and therefore transform what it is that you're trying to do. With predictive analytics, it's about being able to take action that directly affects outcomes because you anticipate it and you know what to do. And so I could stand here all day and I could tell you about organizations that have, massively increased their returns on their marketing, ones that have taken a whole operation and made it hugely more profitable, ones that have been able to, in a very, very short time, for example, make big savings in their fraud, or not so much a feel-good story, but ones that I could tell you about tax authorities that have known where they can look to collect more money from the citizens that hasn't been properly paid, and so on. Over the last 10 years, more and more, we've seen this applied to machines, because we are in an era where we depend very heavily on critical and complex machines. But when they go wrong, we have huge problems. So this whole area of what we call predictive maintenance and quality and optimization has come out and been applied to almost anywhere machines operate. And we've seen that from huge machines like reducing the number of outages in electricity generating companies by tens of %, through to replenishing printer consumables and increasing the profits on doing that by making sure that you use every bit of ink to the last drop. We've had aero engine manufacturers like Pratt & Whitney reducing their maintenance costs while at the same time significantly extending the engine life. We've had rail operators able to move from reactive condition monitoring when they get an alarm signal and so they stop the train or they slow it down and disrupt the network, to being able to predict 7 days ahead with 98% accuracy and plan around that. You have car manufacturers like Honda, like BMW, like Mercedes, able to improve the manufacturing, reduce quality defects in the production line, but right through to being able to monitor things like electric vehicles in real time and accurately predict when the electronics might fail. Everything in terms of energy and resources, from remote gas wells in the outback of Australia and being able to plan your visits to them and know how to maintain them, down to real-time monitoring of mines, of equipment being used in mines thousands of miles away from the manufacturer, who is still advising with analytics in real time how to fix things in one operator's coffee break. And anything from production of hot steel and being able to recognize when a situation might cause 2.5 kilometers of rolled out steel to kink and get stuck in rollers, right through to managing buildings and being able to understand how to preemptively repair, for example, air conditioning and keep it a habitable space. But it's not just about all of these things that do business or production or finance or whatever is better. That's just an application I've always loved from University of Ontario, working with a neonatal monitoring unit. And what this one is often talked about for is the density of information. It's very big data because of the volume of it, because of the amount of data that is coming into it from all the monitors on these mostly premature children. You know, the 120 children monitored at a time, 120,000 messages per second, billions a day, and people with a data fixation get very, very excited about this. But what that really counts for is, because of that data and because of the analytics applied to it, the system can detect infections in these children 24 hours before the trained medical staff can spot the visible signs. And you cannot put a monetary value on being able to do something like that. The thing about automation is it allows the machine to scale the use of analytics way beyond any number, any army of data scientists that you can apply. And I'll give you an example. I was saying earlier, you know, it's fine being able to, say, forecast demand for one item. What happens when you're dealing with thousands or millions of those? And assortment planning is a classic area for this. And if you think about the way that retailers work, you know, think about when you shop, you go in and you expect what you want to be in store. So assortment planning is making sure the right things are at every store. Now, most retailers actually do this in a very simplistic way. They do it as one size fits all, just scaled by the size of the shop, or maybe they've got categories of A, B, and C stores, and there are 3 assortments for the A's, the B's, and the C's. What this technology allows you to do, by combining the advanced analytics and automation, is get down to the level of the individual store. And that is actually quite groundbreaking. Now, the way they measure their success at this auto parts company in the US, in the first 90 days, they had reduced overstocking of the fast-moving goods, the oil and the wiper blades, by $50 million US. But by having the right things in place, the rarely bought items, by having them available to be bought, they'd actually increased the sales of those by over $100 billion US. So that's $150 million payback in 3 months from a single project. Physically impossible to do without the types of automation of analytics that I'm talking about. My final advice to you: ensure projects are driven by genuine business need. These are not science projects. Just by being excited by the amount of data you've got isn't a reason to dive into it. Look at it from a business lens and work out how to work back from that and get the best results. And you know, don't ignore, or don't hire people who ignore decades of work and experience in analytics approaches and analytics tools and so on, and who are going back to banging flints together. Okay, but basically what you need to do is take an industrialized approach, do the right kind of data science in your organization, and you will reap the benefits. Thank you very much.